Hello, everyone. Thank you for tuning in, and today I will be describing using fused neural networks for a multi-sensory approach to human emotion classification. Imagine if your teachers could gauge your classroom engagement on virtual teaching platforms like Zoom just by allowing a computer to analyze your face and your voice. Our group has developed a fused face and tonal recognition model that classifies human emotions when fed video data that could do just this. For our model, we decided to use convolutional neural networks. A neural network is a type of machine learning that is modeled after the human brain. All neural networks contain an input layer, many hidden layers, and one output layer. The input layer is where the model receives data. The hidden layers each do complex math to come up with numbers based off the data, and the output layer uses the numbers produced by the hidden layers to come up with the final number that is the answer to the problem. Convolutional neural networks are a complex type of neural network that compares data to a feature it already knows. Since our fused model will be determining emotions from frames of a video, we first needed to develop a face model capable of classifying emotions from images. First, we gathered data and performed a couple augmentation experiments on that data. The first experiment we did was cropping the data. So first we cropped the first half of the face versus the bottom half of the face, so comparing the eyes to the mouth. And while the mouth pictures performed a little bit better, we found that the model performed more accurately when full face images were used. We also compared the use of colored images versus grayscale images to test if the model had any bias towards skin color, to which we found no significant evidence. Since our fused model will also determine emotions from a video's audio, we needed to develop a tonal emotion recognition model. We used the RAVDES dataset, and we also used a custom LSTM model. An LSTM model is a type of neural network that can store data for longer periods of time. Our 3.3 model had made the most accurate predictions so far using the LSTM, but we decided to take our project to the next step and transferred our model to a convolutional neural network to increase accuracy of emotions such as sadness and anger. For our final fused model, we used a combination of both the tone and face models. It extracted the audio and visual data by breaking down the video into frames. It also used a weightage to determine how important the data analysis from both parts of the model was in its final determination. It analyzed happiness, sadness, anger, fear, and neutral emotions, and it did have some flaws like trouble identifying sadness. However, in the end, it performed with about a 63% accuracy. A couple applications for this model could be in the entertainment industry to gauge customer interest during movies or playing video games, or for determining emotions in healthcare fields where half of a worker's face is covered with a mask. Moreover, computers can also analyze emotions with no bias, unlike a human. Thank you for tuning in, and I hope you enjoyed.